find the speed of rod at any time t. No. So the resistor, capacitor, now a cell which will have EMFE. I'll give the velocity to the rod and I'll simultaneously switch on the cell. What conditions will arise here? So moving rod, we know moving rod should be like, moving rod should be replaced with a cell. So this is the cell. These are all introductory here for you. Different cell will come, inductors next, all resistor. Then tomorrow I'll introduce friction idea. Ideal cell, if it's having an internal resistance, put that small r here. So this is the velocity v at any time t. There's a magnetic field. So let's take this one. So how the induced current should be known. Definitely the velocity what I given, based on that things will be dependent now here. Let's come for what is EMF induced. E equal to what you write. Motional EMF, BLU, the initial E naught. Let me begin with initial at t equal to 0 only. At t equals 0, this is what happens. No? Then whether current will flow or not will determine the value of U. Now I given velocity U such that current due to cell will flow like this. Resistor R, I'll bring it here. It should be brought here. So what is I1? I1 will be due to cell, no? That will flow like this in this direction. This will be the I1. Due to EMF, induced EMF, E naught, also there will be flow of current. And what will be the direction of that? Will be I2. So what is I1? We'll just work out individually first. So what is I1? I1 equal to E by R. What is R? R is the resistance of the rod. I1 equal to E by R. What about I2? I2 is equal to E naught by R. And further this is equal to BLU by R. Now we have this one. So which current will be greater? That depends upon the value of U. Am I right? The statement what I just quoted. So the value of U is such that I2 will be less than I1. Let's assume that I1 greater than I2. The resultant current, how it will be? The resultant current in the circuit will be towards right. So there's a cell here. And here, motional EMF, and there's a resistance R. Let V be the velocity at an instant. This after some time t. At any time t, let I be the current, total current, let it be I. Then how the BIL force will act? The net resultant BIL will be towards right only, check it. The net resultant BIL will act here. Now you can ask question, where is that Lenz's law? Where is that Lenz's law?
Tight resist.
Oh, somebody mute it. So where is that BIL force? The BIL force will act towards right only. The I is the resultant current. Due to I1 towards right, due to I2 towards left. So what is I1? I1 is a cause. And I2 is a, so I1 and velocity are cause. So what happened? I2 is a reaction. So with this, what you can expect, the speed of the rod will increase or decrease here? Will increase in this case. So let's write the resultant equations. Looking at the third diagram, this at any time t, no? MA is equal to BIL. So M dV by dt is equal to I is equal to I1 plus I2. What is I1? E by R. What about I2? BLV by R. So this will become now dV by BE plus B square L square V dt by mr. Then integrate this 0 to initial velocity given u at any instant of time, let v be the velocity. Again, you'll get an expression. The velocity, this will be b square L square by E
I1 minus I2.
1 minus I2, sir.
I1 I minus I2, no? Okay, this one, yeah. What is the final will be BL BEL. So here one L will be there. I'm directly adjusting things. This will be the expression for the speed of the rod at any time t. After integrating all, lambda is some, all constant terms will come. The speed of the rod will continuously increase. So let's talk about the energy now. I'm interested in that energy conversion. Finally, the speed of the rod, this will be the terminal velocity. And what is the terminal velocity? E by BL. So initially what will happen? The energy is supplied by action agent kinetic energy to the rod plus the work done by the cell. What will happen to it? A part of it is utilized to increase the kinetic energy, and the remaining what happen will be used to overcome the heat across the, or remaining is used to generate heat across the resistor. Okay, so now who will supply the energy now? The cell. The energy supplied by cell, a part of is utilized to increase kinetic energy of the rod. Remaining what happen? Heat generated in the resistor. In terms of power equation, what you write? E into I should be equal to dk by dt plus I square R. This one. So in terms of power, E into I should be equal to dk by dt plus I square R dt. So only I square R. Power, no? It is. What all power generated by cell, a part is used to increase the kinetic energy of the rod. Remaining what pen? Power dissipated across the resistor. After long time, at t equal to infinity, after long time, what will happen? So what is the current? So let's, after long time, put t equal to infinity. Terminal velocity equal to E by BLV. So then what is the expression for current? The resultant current will be 0. I think these are some initial currents. Some are asking what about these? These are initial currents. I'll put like this. Some are getting confusion with currents at any time t, and this one initials. Symbols I changed it. I1, I2, let it be at any instant of time. What is I? I should be I1 minus I2. And let's come for this. After long time, what will happen? The overall. After long time, put t equal to infinity. Then what is the terminal velocity will become equal to E by BL. Then what is the EMF induced across the rod will become equal to applied EMF. Initial velocity not equal to, here we are given, no? Oh, that also should be substituted. Okay, there's the equation, initial velocity should be taken care. Some modifications. So then the graph will change here. It should be like this. Okay, there's some initial velocity u given, no? So things will be. So get expression, but things will be same. After long time t equal to infinity, the current in the circuit will be 0. Then no power, no current, no power generated by cell, and there'll be EMF induced, no current flows, and there's no any power conversion will occur. After a long time, the EMF of the EMF induced in the rod will become equal to that of the cell. So what is the net EMF? Will be 0, no current flows, and no it will be generated. The rod will continue to move with a constant velocity. How to calculate the terminal velocity? I directly write it. Since I know this, I'll write it here. This will be the terminal velocity. If you want to check it mathematics,
Initial velocity also.
I didn't solve it. What happened?
Initial velocity also will be in a.
No, after a long time, that's all. No current flows. Then what all EMF generated across the rod should be equal to EMF generated across the cell.